Welcome to part 3 in the Solving System of Equations video. Today, we're going to be looking at how to use the substitution method to solve our systems of equations. Now, this might sound like it might be a little crazy, but substitution is something you've done for a long time in math. It just happens that this time, instead of substituting a number, we're actually going to start substituting an equation. So to give you sort of a heads up what we're going to be doing, think about what you would do for a problem like this. If I said x equals 3, and I said y equals 2x plus 1, how would you solve for the value of y? Well, you would take this 3, and we plug it in. We do 2 times 3 plus 1, 6 plus 1, or rather 7. Y is 7. What we did there is we took that value of x and we plugged it into the equation to solve for y. And that is precisely what we're going to do this time. So here we go. Let's use the substitution method. Now the first thing we're going to do in the substitution method is we're going to look to see if one of our equations has a variable by itself. So in our first equation, we so happen to have a variable, in this case x, by itself. So what I'm going to do is I'm going to take what x is equal to, in this case the 25 minus 3y, and I'm going to take that value, that 25 minus 3y, and I'm going to substitute in for the value of x in the other equation. So I'm taking the value, what x equals from the first equation, and putting in for the value of x in the second equation. So I'm going to take all of this that's underlined and put it in for that x. So what does that look like? 4, it's that first 4. Now instead of writing x, I'm going to write what x equals. I'm going to write what it equals, which is 25 minus 3y. And then I'm going to continue writing that second equation, 5y equals 9. Now why did I do this? Well, if we look at our new equation here, we would notice that now only has one variable. Everything is written in terms of y. We can now solve it. So I'm going to go ahead, I'm going to distribute this 4. 100 minus 12y plus 5y equals 9. And I'm going to go ahead and solve for the value of y. Let's subtract that 100 over, minus that 100 over, combine the two y terms. We get, this would be negative 7y equals negative 91. If I take, I'll use my calculator to double check my work. If I take and divide by my negative 7, divide by that negative 7, I get the value of y equals 13. Now we're not done yet, because when we're solving a system of equations, we need a value for both x and y. Right now, we only have a value for y. To get the value of our other variable, I'm going to take the value that we just solved, y is 13, and I'm going to plug it into one of our equations. I'm going to plug that y equals 13 into one of my equations. So I'm going to pick the first one. It doesn't matter which one you do. The x equals 25 minus 3y. So I'm going to plug my value of y in. Let's do that right here. X equals 25 minus 3y. Well, we said that's 25 minus 3 times 13. It's 25 minus 39. I'll grab my calculator again just to double check my math. Now I'm going to get negative 14. So my solution, my xy point, is negative 14, 13 for this equation. Again, what I did is I took my first equation. It doesn't always have to be the first equation, but because the first equation was x by itself, x equals something, I'm going to take what it equaled, that's something, I'm going to plug it in for the second equation. Let's try another one. Here we go. Now, for the second problem, is there a variable by itself? Well, that second equation just has a y, but there's that 2 in front of it. In that first equation, there's a few different ways we can go about it. There is no right or wrong answer. Let's start with that one. There is no right or wrong way to do these. Personally, my personal opinion, if I were to do this problem, I would try to probably get this x by itself by subtracting that 2y over. If I subtract this 2y, that first equation turns into x equals negative 2y plus 14. And the reason I would do that is, sure, I could get this in the second equation. I could have gotten that y by itself, but then I'd be dividing by 2, and then that's x over a half, and I'm not a huge fan of fractions. So I'm going to use this x equals this negative 2y plus 14, and I'm going to plug in that negative 2y plus 14 in for the x in my other equation. I'm going to plug that in for the other equation. So if I do that, I get 2y equals, I'm writing my second equation now. Instead of writing my x, I'm going to write what x equals, negative 2y plus 14. Finishing out my second equation, minus 10. Let's combine some like terms. So let's combine the 14 and the minus 10. Negative 2y plus 4. Let's continue solving for y. I'm going to add that 2y to the left side. When I do that, I get 4y equals 4. Solving for y divided by 4, I end up with y equals 1. Again, I'm not done yet. I still need to solve for my value of x. So I'm going to plug it back in to one of my equations. Now, it doesn't matter if I plug it into that first equation on the top, the bottom, or my simplified one. All three of those would work. It does not matter. I'm going to just use my simplified one just because the x is by itself. So let's say x equals negative 2 times 1 plus 14. X equals negative 2 plus 14. X equals positive 12. So I have my x value, I have my y value, so my final answer is positive 12, positive 1. Again, I solved using substitution. Difference for this problem is I had a first, I'm not drawing on the screen. Difference with this problem is I first had to get one of my equations by itself. And that is one of the drawbacks to the substitution method. You do have to get a variable by itself. Again, let's do one last problem, finish it up. Again, is there a variable by itself? No, there is not. So let's get one by itself. Which one do you want to get by yourself? Completely up to you. I like to try to find a variable that has a coefficient of 1. It's positive. So personally, I would try to get that first y by itself. To get that first y by itself, I'm going to add the x over. And I'll have y, that first equation turns into y equals x plus 4. So now I have y equals something. I'm going to take that value and I'm going to plug it into my second equation. So that second equation is 3x plus, now instead of writing my y, I'm going to write what y is equivalent to, what it's equal to. X plus 4 equals 16. Let's do a little simplifying. Let's combine our x terms. We get 4x plus 4 equals 16. Again, we're going to solve for the value of x. 4x equals 12. And x equals 3. Are we done yet? No, we only have one of our variables. We need to get the other one. So I'm going to take my x equals 3 and I'm going to plug it back into one of my equations. Which one do you want to use? Again, doesn't matter. Let's use the simplified version because, well, we can and it's already solved out there. Y equals x plus 4. So we'll say y equals x plus 4. We said x was equal to 3. Y equals 3 plus 4. That means y equals 7. That means our final solution for this problem is going to be the point 3, 7. So again, substitution method. What we're doing to solve an equation, to solve a system of equation, is we're looking to take part of one equation and plug it into the other. Substitution, graphing, they're just two of the different tools that you can use. They're not the only ways to do it, and sometimes you can go back and forth. It just depends on how the problem is set up. If they're both set up as y equals something, sure, you could graph them. Problems like these, you could also do substitution because we can very easily get a problem by itself. I encourage you to practice, give them a try. Let me know if you have any questions. Otherwise, have a great day, be well, and I'll talk to you later.